Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is path with maximum gold. So you are given a grid representing a gold mine of size m cross n, and each cell in this mine has an integer representing the amount of gold in that cell. 0 means that there is no gold in that particular cell, and return the maximum amount of gold that you can collect under the condition given conditions. Okay, so what are those conditions are as follows. Every time you are located in a cell, you will collect all the gold in that cell. Okay, not leaving anything behind. From your position you can walk to one step, uh, left, right, up or down, so four directions you can go from current cell. Okay, four neighboring cells of current cell. So you cannot visit the same cell more than once. Okay, so it will be not like that. You, for example, let's open the board. So let's say this is the matrix given to you, or the grid you can say, representing the gold mine, and currently you are here, and then you decided to go here. Then you cannot come back to this initial starting point. Okay, so this is not allowed. So never visit a cell with zero gold. So you will avoid visiting empty cells which are not having any gold. You can start and stop collecting the gold from any positions in the grid that has some gold. Okay, so the starting point from where you will be start collecting your gold can be any cell in the grid, provided that that cell is having some gold. Okay, and these are the conditions that you have to follow, or the constraints you can say. And before thinking of an approach, let's have a quick look at the constraints for the problem. So the number of rows and columns will be of order 15, and each cell will be having a value from 0 to 100, representing the amount of gold that cell is having. Okay, and it is mentioned that there will be at most 25 cells in the whole grid that is given to you which are containing gold. Okay, not greater than 25. Okay, so these are the constraints. Now let's think of an approach to solve this particular problem. Okay, so a very straightforward approach that is coming to my mind is, we will traverse or iterate through every cell of the grid. So go through every cell of grid, and if that particular cell is having some gold, then you can pick this cell as the starting point of your exploration path, which will lead you to collect some amount of gold. Okay, so then you for exploring for the exploration path starting from a cell which is having some gold, you can apply a simple DFS, depth first search. Okay, so those of you who are not familiar with what that first search is, it is nothing but you start from some point and then you keep traversing that path until you reach a point where you cannot proceed further. You come back and then explore other options. Okay, so it works like this. So you go down the current path till the very end, and if you are not able to go further any further, then you come back one step at a time, and after coming one step you see are there any more paths that you can explore, then you will go on those paths. If there are no paths, then you come one step further back. Okay, so this is in nutshell what DFS is. Anyhow, I will try to find an article explaining what DFS is and how and when to use it. So a link will be provided of an article to you. So simple DFS will be there, and how many directions we will be allowed. Theoretically speaking, we are allowed to go in all four directions, but in the problem statement constraints or these rules, it is mentioned that you cannot go back to the cell from where you came. So you are only left with essentially three choices, but theoretically, as per the problem statement, if we are not considering the constraints, there are four choices. Okay, so a simple DFS will be sufficient. And if we talk about what will be the time complexity or the number of operations that will be required, if we take everything theoretically and we take a upper bound, then it will be, let's say, G is the number of cells containing gold, number of cells containing gold. Okay, then the time complexity will be order of, since you can start from any of these G cells, your exploration path can be started from anywhere from these G cells. So G order of G into, then from each starting point and each you know cell on that path, you will be having essentially four choices. So G into 4 raised to power G, okay, will be the number of, you know uh, an upper bound, you can say, for time complexity for the number of operations that will be required. Loose upper bound, you can say. Okay, and with after seeing the implementation, you will understand that the actual time complexity in the real case scenario will be a lot lesser than this theoretical loose upper bound, because of many things that we will be using. Firstly, we will be using pruning. Pruning means that the path which is not looking very promising, you will avoid that path. Those paths can be the paths leading to a cell with empty gold, okay, or the path that is leading you backwards, as the problem statement mentioned that you cannot go back. So because of that, and because at certain points you will hit the boundary of the grid also. Okay, so you cannot move past the boundaries of the grid. So that is one thing. So in reality, time complexity will be a lot lesser than this particular time complexity, but theoretically it will be this. Okay, and if we talk about space complexity, I think we should discuss after having a look at the implementation. Now, without further delay, let's have a quick look at the implementation. Okay, so I think the implementation code is not that much, lengthy, so it would be fine if we just take it to the board. Let's try to adjust it on the next slide. Yeah, it is very well adjusted in the current slide. So let's discuss what's happening here. So first of all, you will be given a grid. Okay, then these are just variables to hold number of rows and number of columns, dimensions of the grid. This memo array is of no use. I was trying to use memoization here, but it is getting accepted even not using it. So anyways, proceeding further, this is just we checking each cell of grid that is having some gold. So each gold containing cell can be a starting point of our current exploration path. Okay, so if the current cell is having gold, then we will start a DFS and start a exploration path from there. So this is the DFS. These are essentially the four directions that we are allowed to move. If you are at 0 0, then there are four directions that you can move to. Okay, so this array represents that. Then comes the method DFS, which is having three four variables or four input parameters. The first one is the grid that is given to you. Second and the third one are the coordinates of the cell from which you are starting your exploration, or the current cell at which you are at in your exploration. And the fourth one is the total gold that you have accumulated till now. Okay, so initially you will not be having any gold, so it will be 0, and these are just the coordinates of the current cell that is having some gold. Okay, and this is the base condition. We will talk about it later on. Firstly, what we will do, we will store the current gold value somewhere safe, because we will be using backtracking here. uh, because as I told you, when you are reaching a dead end in DFS, you will backtrack one step back and then try to explore for further paths. Okay, so that's why, and it will also help you to avoid going back to the same cell, the constraint that is mentioned in the problem statement, if you have you know paid attention to. So this is mentioned in the problem statement that you cannot visit the same cell more than once. Okay, so what we'll be doing is, we will be marking the current cell as a non-gold cell. Okay, we will consume everything that is there. Take away the entire amount of gold. Okay, and the total gold will be increased to the amount of gold that was present in the current cell. Okay, which was this amount. You can also take gold value, it is totally up to you. And then you can see that we are exploring the four directions from the current cell. So to generate the new coordinates, we are just using this array in combination with the current coordinates. Okay, C and R. So then we will generate new R and new C, the new coordinates of the cell that we will be proceeding to. Okay, and yeah, this is what will essentially happen for every cell that we are visiting, exploring four paths. And once we are done with it, then we will again restore the gold value. Okay, because now this gold value may be used for another path, uh, starting from any other cell. Okay, in from these two loops. So reinstating the value or the amount of gold in that cell that was previously there. And this is just a function to check whether you are within the boundaries of the grid. Okay, that is one. And another is that you should be visiting a cell which is having some gold at least, because in the problem statement constraints it's mentioned that never visit a cell with zero gold. Okay, so it's to just check whether you are visiting a safe cell or not. Okay, safe cell is considered a cell which is well within the boundaries of the grid, and it is having some gold at least. Okay, so, and this is the base case. In case you are visiting some cell which is outside the boundaries, or it is not having any gold, in that case you will update a variable which is initially set to 0, which is maximum gold that you can get. Okay, and yeah, at last we will return this variable maximum gold. So this is how whole thing will proceed, or this is the logic you can say, and implementation. So space complexity, we were talking about that, we will discuss at the end. Now let's have a quick discussion about space complexity. So as you must have seen that we are not using any extra space other than the recursion call stack in this DFS call. Okay, so this DFS call. So what is the space that this recursion call stack will be using? Okay, if we take an upper bound, it will be not more than the number of gold containing cells. I mean, the entire DFS path or the path that you will be visiting cannot have length more than G, which was the number of cells having gold. So it will be order of G. Okay, G is the number of cells having gold. Okay, so these will be the complexities. Time complexity, I again would like to stress upon that it will be very less than the theoretical time complexity that we have just discussed, because of the pruning and this out of boundary conditions that we will encounter while moving from one cell to another. Okay, and what kind of pruning is this one? I mean, pruning is happening because of both of these conditions. Sometimes you might go out of the boundaries, or sometimes you encounter a cell which is not having gold at all. Okay, so in a real case scenario, time complexity will be a lot less than that. That's why this is getting accepted. Okay, so let's quickly remove this memo part, and try to resubmit it, just for the sake of showing you that it's getting accepted. So as you can see, it's getting accepted. Okay, so if you are still having any doubts or any queries in general, then you may ask them in the comment section. I hope this problem solving session and this solution walkthrough provided or added some value to your journey of owning your DSS skills. And I will see you in the next video. Until then, keep solving problems and keep practicing. Thank you for watching.